Okay, yes, so welcome to this warm welcome from Vienna, firstly, to everyone who has joined us outside of the studio and outside of the original, let's say, group set up for this meeting. So my name is Jakub Tits, and I'm welcoming you in the name of our digital architecture and planning department at TU Vienna. We are running this Ecolabs design studio with Professor Michel Hensel, Elisa Bujavlic, and Tina Salami, and we are doing this kind of a digital architecture and terrain modeling together with the students in our studio. And this work is a part of the Ecolabs project, which is financed by the European Union. And it's about the game-changing design approach for urban ecosystems. And here's the webpage. So the project really is a group effort, which is supported by EU, and also there are so many universities and companies involved in this, among others, the McNeil Europe and Studio Animal Aided Design. And we are a mixed group of architects and ecologists who participate in the project. And today we'll have the meeting with Chris Landau and Ben Same, who will be showing us the Landkit plugin for Rhino. When you look at their webpage, what you could see that they're making rocket fuel for design. So I knew Chris from before, but when I saw this statement, I was like, yeah, it sounds like something that our students would really need. So that's why I asked Chris to basically give us the workshop or give us the chance to learn something about the Landkit. And there is Chris trying to give us a hand on these amazing tools which you could use to distribute plans, design freeform geometry, and link the constructed elements with natural landscape. So yes, Chris, I'm allowing myself to introduce him. So he's a designer and consultant for large urban scale landscape projects. He works with large American architectural practices and also public and government organizations. He's an artist, designer, professional landscape architect, educator, and software developer of Landkit. And he's doing a lot of projects in different scales, right? So there would be something like a master plan of LA, some animations and other media for the Los Angeles Zoo. There's a very interesting topic of the 3D printed animal prosthetics. He's doing also the coding for Landkit and many other projects. But Chris is also a person with an incredible experience as a professional landscape architect, working at high-profile projects at the time with All In. So many of us architects know those projects from the architectural part, but it's also the landscape which plays a very important role in there. So Apple Park, made by Foster and Partners, Google Mountain View, made by Big and Hedwig Studio, and the Pier 26 in New York are some of the projects on which he worked in his previous experience. And it's a great pleasure to have Chris in here and have his unique kind of understanding of the, let's say, the tools to design, and at the same time, a perspective of a practicing landscape architect. And today, Chris will be also, let's say, supported by Ben Same, who is working with Chris in Landau Design and Technology and working on Landkit. He's also an artist and designer because he graduated both the Master of Landscape Architecture and Bachelor of Arts. He's a passionate teacher, and he was teaching digital media and landscape architecture during his studies. And he worked also internationally for nonprofit goals in humanitarian aid and to build the community gardens in Detroit. And I don't know exactly on which of those projects Ben was a part of, but for sure he's a very important part of the team that Chris is building for his practice. Okay, so this was the quick introduction, and now I'm handing over to Chris.
Thank you so much, and thank you all for joining. And the introduction was excellent. I think I need those slides.
No problem.
Yeah. So I don't know if I'm not sure if I'm showing up or not. But
yes,
but
we can see you.
Okay, I'm going to share my screen, and I'm really going to dive right into our example that we have. Partly because we've recently given a talk to McNeil Europe for their Food for Rhino webinar series. And we showed some examples in that webinar, and in a way that's like the prequel to this little discussion. And we're going to try to cover some higher level topics, but sort of in the context of our demo. I highly recommend watching that video, and Ben's going to post in the chat. We also have a few other links that you should check out that we may be posting along the way, relating to the Landkit website, our campus resources, which help, they have like learning resources and references for Landkit. And then there's a few other links as well. Our Instagram, which I think appears there on that title page. If you're watching the recording, you can just go back a minute. So this is we call this project, this little example project, the Alligator Cafe. And the idea here is that, and this is the reason we're using this example for the Ecolopes folks and for Jakub, is because it takes an example that integrates architecture and landscape together. And we wanted to both look at what is the workflow for that, and also, what are some of the challenges or things that we have to think about when we're doing this kind of thing, and really pulling architecture into the conversation of the landscape, and thinking of, and I know that's a topic that you guys have been talking about, and how does an architectural entity become part of the environment, or be thought of as part of the landscape. And we have some different answers to that. So if you look at this view, the other thing I wanted to show you, okay, I thought, I'm having a few Zoom things. We are also going to show you, so there's this sort of topographic coordination, as to how does the roof interface into the landscape. And then secondarily, there is, the plants that you saw a second ago, but we're going to talk a little bit about how there are different ways that you can use rules-based planting to generate different ideas. So these are, okay, there we go. I had two layers on at once. So this shows kind of a very color-focused planting design, whereas the other two are maybe slightly a bit more focused on just the kind of environmental constraints needed to place the plants. So let's turn off some of these bells and whistles here for a second. And the paving was achieved using Paving Kit, which is honestly one of the easiest tool sets to use. We're using maybe a slightly more advanced example of it here, where we're coordinating two different paving patterns together. But the whole point of all of this is to be able to have inputs that are easily manipulated, like simple geometries, and then to have the site sort of constructed for you in a way by the script, so that you're not focused on doing all of this sort of manual work. You still have control, and sort of what we're part of what's happening here is that we have this kind of exploded axon that has some different factors involved, and some of these are related to planting and some are related to the topography. But let me get into the topography really quickly here first. So the first thing we're going to look at is our topo script. I'm going to turn off our materials. We have materials for both the ground and the roof, and we still have our walls turned on here. But let me unlock this Grasshopper script. So this is our topography workflow, and we're using Topo Kit. And the idea here is that each of our little, you know, components or little sort of clusters that we're building pull in geometry using, in many cases, the geometry pipeline. So this is a great example. So this pulls in 2D curves that we've drawn for walls, these green lines, and then it pulls in 3D spots for the wall front and the wall back. So if we zoom in, you can see that we're defining the back top of the wall and the front bottom of the wall. And we can do that at different spots along that wall, and that will change the height of the wall by interpolating in between those points. So those are coming in automatically. So if we make any changes, if I open up my topo layer here, if we make any changes, so if I take, here's a good example, this wall over here, doesn't bother anybody too much. So if I pull this up, it's going to update the wall. And I'll show you kind of the pipeline here, but it updates the wall, but it also updated the grades. See how it changed our topography as well. So I'm going to undo that because that's an undesirable change. And then we're going to go and look at sort of what happens. So the neat thing here is that it pulls in the spots and the curves for all of the walls. So we have 8 different curves, you know, the front and back of 4 walls. And then we have 21 different points. And Ben and I have had projects where we have hundreds of spots and, you know, almost 100 curves in some cases, where we're creating whole streetscapes, and we're these curves are all getting figured out dynamically by one component, which is really, really exciting. And this just automatically pulls all of those things together using the tolerance between the curves and the tolerance between the spot and the curve in plan. And that creates wall objects, which is interesting because most of the time in Grasshopper, you're going to see geometries going in and geometries coming out. But in this case, we have a special class that we've created for walls. And we do this for a number of things. We do it for plants and for the kind of environment, and we'll see that with the planting design. We do it for topography and also like paths and stairs and other things that we can use. And part of the reason we do that is that we have mods. So you can take this wall and we could add a few modifications to it. So we could give it a top of wall that's higher than the retaining aspect of the wall, or we could, if it was a curb, we could add a curb cut, and in that, but just by adding a cross line and then some different parameters for the cut of that curb. So so we have some other inputs. So not only do we have walls going into our topography, so you can see here we have an input to create topo, but we're also using what's called a geoset. And the geoset pulls from a whole layer of geometry. So we define the layer. In this case, it's topo, and then the sublayer is terra firma. You get the sublayer by doing the 2 colons there. And we have these layers that are underneath that we can place different things on. So the big thing you can see are the break lines. So if we manipulate these break lines, the topography will change. So if I just, for example, grab these curves and I move this point up. Oh, I have to refresh. Pardon me. So some of these, we've created a refresh button for some of these because we want people to be able to make a bunch of changes before they actually hit go, because sometimes if you're dealing with a more complicated site, that's a better workflow, because you don't want to necessarily be constantly having those updates. So you can see how dynamically that changes. Pardon me. We also have live analysis tools. So the topography that's coming out of the pipeline we can analyze in different ways. So we can see the the depth map of, you know, the elevation, and we can also do the slope, right? So we could see the slope. So I could in real time, if I just undo here within Rhino, that point moves back down. I hit refresh, and it's going to automatically change all of the grading and update the analysis in real time. Oop, I clicked on the wrong refresh button, pardon me. There we go. So you can manipulate and say, you know, you could say, oh, that's too steep or whatever. I'm not gonna make a lot of extensive changes for the interest of time today, but we do have an example we could share of a time lapse manipulating a bunch of, you know, actually changing this whole alligator. So the other cool thing is we've created the topo, and then we can add in mods. And the first mod is a smooth mod, and we kind of select a certain area and we can smooth out the topography using, looks like we have a boundary that just, you can see that down there, that green boundary. And then we have a sculpt layer and mod that pulls in these points, and these points are what are creating the mounds. So given a parameter, a height parameter, and a spread for that mound, and the points as an input, it's going to push those mounds up. And it's maybe a little easier to see that under elevation change. So you can see that. And the neat thing here is that we're not grading with contours. Grading with contours limits us immensely, because it forces our hand to smooth everything out, to simplify everything. But if we want to make kind of radically ecological design moves, we have to be able to make the landscape more rough and kind of rough it up and create more niches for plants and creatures. And so the neat thing here is that we can make these manipulations with very simple geometries, simple parameters, and then our output is contours rather than the other way around. And we're not reliant upon trying to do these complicated things with contours. And I think this is the future of grading. And of course I would say that. But so we have break lines and walls that all help create the topography. And then you can take, so you know, once you make these modifications, we use these components to make modifications, then we draw the topo. And the neat thing about that is you can change the settings for how the topo gets drawn. So you can sort of think of it as a variable resolution topography. So you have all these inputs that are always the same, but then you can, at the very end, change the rules for how it's drawn, which is kind of great. So if you're dealing with a more complex terrain, you can have a lower kind of quality up until the point where you're ready to have that final mesh for rendering or whatever. That topo, before we draw it, we're actually going to take it and it's going to come down here, and we're going to make another mod to it, which is a patch mod. And the neat thing about the patch is it still requires an input of a geoset, which we get from a series of geometries. So if I select all the sublayer objects of that, we have some break lines that define our roof. And then we also have a boundary down here in purple that defines, let me just go and plan, that defines that area. So all our terrestrial grading is defined here with you know, the break lines, but then we kind of have this sharp, you know, I think there may actually be a wall here that we're using to define. It's a little confusing to see that roof on top, but we have you know, the conceptual approach here is that this would be a retaining wall. This would all be earth behind it. And that might be I could see varying that strategy a little bit so that maybe you have a setback or something like that. But conceptually, that's sort of what's happening. We can use this geometry to calculate things like cut and fill and what have you, and in order to understand what's happening on the terrestrial, grading. But then we also have the ability to see. I'm going to plug in the other mesh here into our analysis. And now this includes our roof mesh, and it creates one continuous mesh, which helps us to do some other things. And that's but you could also build that mesh separately if you wanted to, right? You could have a coordination edge. But right now, that's just sort of how we have that built. Let me turn the analysis off for now. One other thing I wanted to point out is that we are doing one other topo, which is completely independent of both of these, which is a topography that defines a slab underneath, because that slab is important for, might be important for drainage, right? You might need to think about drainage on your roof. Very often the waterproofing layer is below all of the foam, below all of the soil. And a civil engineer might even say that that is the level you need to think about for water. We do, of course, look at water as well, but we are kind of looking at it a little bit more superficially on the top. But the cool thing is we've added this water flow, which you've probably seen scripts and other examples of this, but we thought it was really important to have this as a utility within our tool set. And we're actually working on expanding our water tools, which is we're really excited about, and we can't wait to sort of share more about that soon. But the neat thing is that you can see that the important thing for the design aspect of this is that not only are we not grading with contours, but we're also grading with simple geometries, and we can see what's happening. We can see where the water is going. And this is one of the most critical aspects of grading is designing where does water go. So, even if these flow lines aren't perfect, like in this case, this pauses here because it gets a little hung up. It doesn't actually flow here, but you can see clearly that it would in real life. Like if it filled up, the tiniest bit, it would flow beyond. And we're recognizing this issue, and we're going to be modifying our flow algorithm in the way that this gets drawn. But we do have some other fun things we're doing with our flow diagram. So that's flow, that's topography. The other really cool thing that we have in Landkit are areas, and areas allow you to draw 2D flat surfaces to define your materials areas. And so we like surfaces in Rhino, especially because surfaces are infinitely editable, right? So you can trim a surface, you can untrim a surface, you can remove a hole, and they're really, really it's like paper, but even better, because you can expand it, you can uncut, which you can't do with paper. But the other neat thing we've done is we've created this tool called the collage tool. And so you can see here that we have our little sort of slug beaver thing that is sort of maybe like a different soil or something like that. Like, maybe we wanted to find, a different material. But this is really great for paths versus lawn versus ground cover and things like that. And you can really in plan layer all of these different things. And the collage tool automatically flattens everything out before projecting it to the topography. Okay. So it automatically cuts out these different shapes. So if I were to go and bake this, and now I go to my materials, I have a separate shape here and a separate shape here. And we're actually, this is a new development. We've added sub D to our areas so that it essentially creates a mesh that's projected to your topography. And then sub D, and that just gives you just this really smooth geometries for diagrams or renderings, you know, we love it because it works pretty much just as fast as meshes. The one thing you want to watch out for is that you don't want to try to cut contours through sub D. It's really, really slow. So usually what we do is we convert the sub D back to a mesh if we want to get those kind of smooth contours, and it's super fast cutting through a mesh. You just have to do the conversion back. So anyways, so that's a fun thing. And so right now we've got areas that are being projected to our sort of the terra firma, and we also have areas that are being projected to the roof. So and it's just one area. It's just that little green patch there. But as we know, especially with this sort of scenario, there's a lot more to it than just the surface. So if we wanted to begin to see how to construct this, we have some new tools. And this, I'm just calling this layer cake because it illustrates it very clearly. So typically what you'd have is some soil, some foam in order to create topography without having the heavy weight of the soil. So because if you use all soil, I just visited the Facebook campus and they had a lot of soil, but they had to drive you know, into the ground like 50 meters for the structure to hold all that soil on top of the structure. But we have a tool which is called our draw areas as slabs. And if you give it your top terrain and your bottom terrain, and then you give it the area shape, it will draw a slab that describes the whole three-dimensional, you know, piece. And what we've done here is we've said, okay, get the top of the ground and move it down 1 foot to make 1 foot of soil thickness. And then we have our roof slab, which we drew earlier, and move that up half a foot, or, you know, also known as 450 millimeters. Yeah. And then so what we do here is we say, all right, put those into a little list. And so we have our top topo and our bottom topo coming in for each branch of our data tree. It's a little bit of slightly more advanced grasshopper stuff going on there. And then that draws our slabs. So those slabs can be drawn either as meshes, but also as surfaces if you wish. And then we have a color for each. And then the cool thing is we added a little, this is the fun grasshopper part, we've added a little slider to do our exploded axon. So you can see all the layers. And you can see the foam and the soil on top and in your slab underneath. And so the neat thing is you're sort of working in an exploded axon, and then you can visualize at the end in an exploded axon. So normally this is just used as like a visualization tool at the very end for something. But the neat thing is in this scenario, you're working in that way, which is really very useful to the designer, right? It's not just a thing the designer uses to communicate at the very end of the process. So that is planting and, topography. And one other piece I'll show you really quickly is the walls. So the walls, we used the walls as an input, but that was kind of the wall class. In order to sort of actually see the wall after we've created it and added modifications, and we're hoping to add more mods, and this is why we have these 2 steps. It might seem a little like if you're just making a wall, it might seem weird that you have 2 steps in order to actually make it. One of the outputs, it's interesting because one of the outputs for the wall are the curves. So there is a preview. So if you haven't drawn it, this is like the fast preview, the top curves and the bottom curves of the wall. But drawing that surface is a little bit more intensive. And part of the reason we save that is in case you want to be able to turn that off to speed up your script, right? That's another reason. Oops, don't don't quit. The command for previewing is Control Q, but if you're in Rhino, it'll my shortcut is quit. So yeah, so this will draw the wall, and it draws the mass of the wall, but it also will show you the spots and the, so it gives you all these are the things that were used to kind of create this wall if you need those for some other thing. And this workflow is very solid, but the cool thing is that people can, they can add their own mods in their own order, and they can structure this however they need to create, multiple levels. One of our workshops creates like 4 levels of grading within kind of like a more architectural landscape, where if you were to like layer and have these different layers connecting. And then we really love to use Elefront to do our baking. And we always use a named bake. And the neat thing about that is if we need to update, if we want to update, like say these geometries that were in our file. So when I clicked bake on those areas, it replaced my old green, green only area here, and it replaced it with this one and this one, right? The brown and the green. So that's another really nice thing that we like about Elefront. It's mainly the baking. We may make our own bake at some point because we use this so often, but I can't say enough about that set of tools, and we use it for baking blocks as well sometimes.